All right, so we're going to talk about cross products today. Now, this is really nothing new from anything that you've done before. It's kind of a formalized shortcut, and I'm a little resistant to show it because one of the mistakes that gets made is once you learn cross product, you want to use it in all the wrong places. So let me caution you right now by saying you are allowed to use the cross product method only when you definitely have a proportion. If you have a proportion, you're allowed to use cross product. Otherwise, you're not. You're not even allowed to use the words. It's just a formalized shortcut. So let's look at it. Over here on the left-hand side, I've written A over B equals C over D. Because there's an equal sign between them, I have a ratio equals another ratio, so I know that this is definitely a proportion, and I'm allowed to use cross product. Cross product says that I can solve this by multiplying the denominator of one side into the numerator of the other side and the denominator of the other side into the numerator of the first side. And this would leave me with A times D equals C times B. Now, it hasn't necessarily solved this for us. There's still going to be more steps to solve a proportion that you've used cross product on. It just says that if the proportion A over B is equal to C over D, then it's also true that A times D equals C times B. So that's the cross product in a nutshell. Let's do some problems with it. Tell whether the ratios form a proportion. So remember up here when I said that this was definitely a proportion because you had a ratio equals a ratio. If I had been given 12 over 30 equals 18 over 40, I'd be able to say, yes, they are proportional. But I was not given a proportion. I was only given two ratios. So it's up to us to decide whether they're equal to each other. So the simplest way to do that is, let's take it over here and do a little side work. 12 over 30, if I reduce this as far as I can, well, 12 divides by 6, seems like the biggest common factor is 6. If I divide 12 by 6, I would get 2, and if I divide 30 by 6, I would get 5. So I know that this ratio is the same as 2/5. So 12 over 30 is the same as 2/5. Let's look at 18 over 40. Let's see, what's the biggest ratio? I think 18 to 4. I think 4 might actually be our biggest factor. So 18 doesn't even divide by 4. What am I talking about? Let's just do it simply. 18 divided by 2 leaves a 9, and 40 divided by 2 leaves a 20. And these do not have common factors. So 9 over 20. So these are not a proportion. All right, let's do one more example. Let's see if I'm lucky enough to pick one that is a proportion. Let's do 28 over 8 and 42 over 6. So I'm going to work in the scratch area. 28 and 8, I'm going to start there, and I want to reduce this as far as I can. 28 divided by 8, 28 divides by 2, let's just do simple 2's. That would be a 14, and 8 divides by 2, leaving 4. Both of these still divide again by 2, leaving a 7, and 4 divides by 2, leaving a 2. So I have 7 over 2, and then 42 over 6. Well, let's see, 42, I think 6 and 42 both divide by 2, so I'd get a 3 under 6. 6 divided by 2 is 3, and 42 divided by 2 is a 21. Oh, but look, 21 divides by 3, leaving a 7. So I get a 7 in the numerator, but I get a 1 in the denominator. These are not a proportion. All right, so these are problems I picked out of the book. randomly. I was hoping that I would get one that was a proportion and one that was not a proportion, but hey, this happens sometimes. So I'm going to have you practice some. If I had gotten the same thing in the most reduced form, so if I had, for example, in the first example, if I got 2/5 by reducing the first ratio and then had gotten 2/5 by reducing the second ratio also, then I would know that they form a proportion, because even though they look different, they are the same value. Okay, here are 3 problems I want you to practice. I want you to do the exact same thing. I want you to take it off to a scratch area so you don't mess everything up here looking at it, and then do your prettiest work in your workspace and all of your scratch work off to the right hand side. Reduce each fraction or each ratio and see if you get 2 equivalent ratios when you're finished. If you do, then you know you have a proportion. Alright, so now that you've practiced up simplifying and reducing fractions, we're going to move right on to solving the proportion, or solve proportion. Now in this case, you don't even have to ask yourself, whether or not this is a proportion, because they've given you an equal sign, which means that it definitely is. Whenever you have the equal sign between 2 ratios, you already know it is a proportion and you don't have to worry about checking it. So let's look. Well, first, the rule about any kind of a fraction is that you always reduce, and you always reduce as soon as possible. So I think I can pretty clearly see a reduction from 16 to 36. So if I reduce 16 by 2, I have 8, and 36 divided by 2 would give me 18. And I can keep going from here, because 8 reduces by 2 giving me a 9. 18 reduces by 2 giving me a, 8 reduces by 2 giving me a 4. I was thinking ahead of myself, and 18 reduces by 2 giving me a 9. So my first fraction is really just 4/9 equals, and look at this, 4 divided by 2 is the same thing as, I have made a mistake, I'm sorry boys and girls, look at this, it's actually 4 over d. Make that erasure. Okay, so 4 over d does not reduce anymore. All right, so now what we want to do is use our cross product. I have a ratio equals a ratio. It is definitely a proportion, so now I can cross product. So I'm going to multiply 4 times d, and then I'm going to multiply 9 times 4. Okay, now all I have is an equation. D times 4, well, I want to get d alone. 4 is next to d by multiplication, so I'm going to transpose the 4 to a division. And that's d equals 36 divided by 4, which we already know equals 9. So if I check that back into the original problem, I can say, well, 16 over 36 is 4 over 9, and 4 over d equals 4 over 9. That's my d. And in fact, that is solved. I have found the d that would make this true. Now, let's be fair here. I went through this whole process. You could easily at this point have said, well, if the numerators are both 4, then the denominators have to both be 9 in order for this to be true, and you could have skipped this whole step. I'd rather you don't while we're learning this, but I certainly get it. If you see that, then I would let you skip that step. So let's do another one. Let's do 30 over w equals 24 over 12. Okay, so this time I've put the variable, so I know there is a variable, that's important, and I'm going to reduce this second fraction. 24 divided by 12 is really just 2 over 1. So 30 over w equals 2 over 1. Cross product. Multiply 1 times 30 and I get 30, and equals w times 2 and I get 2w. Now w times 2 equals 30. That's just because I like my variables on the left hand side. I'm going to transpose my multiplied 2 into a divided 2, and I have w equals 15. Let's do one more example, and I have a specific point I'd like to make when I do. So let's do example 5. T over 12, ooh, I love when my variables are already in the numerator, equals 20 over 8. Okay, well, let's reduce our 20 over 8. See why I'm going off to the side? Because it would be hard to work with these two values when I cross product. So I want to work off to the side so I get really pretty work that I can work with when I cross product. So 20 divides by 2 leaving 10, 8 divides by 2 leaving 4, 10 divides by 2 leaving 5, and 4 divides by 2 leaving 2, so it's 5 halves. So I have T over 12 equals 5 over 2. Okay, well, when you cross product, and you probably already noticed this, but I just want to make it as clear as possible, you're going to stay on the same side as the numerator value. So when I multiply 2 times t, I'm not going to end up with the 2t down here in the denominator. That's why I put the arrow in, because you're going to take the 2 up to where the t is. So it's in the numerator with the t. And you're going to take the 12 up to where the 5 is. And then from there, you're going to go ahead and solve that out. So let's see, that would be t equals, notice I'm also not multiplying out my 2 and my 5, my 12 and my 5 before I divide by t. I'm going to show you why. I just think it's smart not to do it until later, and here's the reason. Because rather than multiplying 12 times 5 and getting 60 and divided by 2 getting 30, that's pretty easy to do, but sometimes the numbers aren't so easy. If you leave it in factored form, remember you can cancel factors. So 2 divides 2 leaving a 1, 2 divides 12 leaving a 6. So that means I'm really just multiplying t equals 6 times 5, which equals 30. And that is so much easier when the numbers are big and complicated. All right, so a couple problems for you. All right, so 3 of them to practice, and yikes, notice we have a decimal problem. And I think we've talked about this 1,000 times in class, but I'll say it again. When I have a decimal, I like to convert it not to be a decimal. So I can move this decimal one place to make a 6 in the numerator, and in the denominator then if I move the decimal one place I end up with 6 over 30. And then I have a fraction to work with. So when you have a decimal, you want to try to convert it not into a decimal before you start manipulating it. Let me give you another practice problem since I just sort of did most of that problem. Let's do 26 over p is equal to 13 over 0.4. All right, there you go. Okay, so one last topic to cover. It's exactly the same topic. The numbers are just a little bit wonkier. So we're going to solve a couple more by cross product. Which means that we have to have a proportion. So I either need 2 ratios that I test to see if they're equal to each other, or I have to have an equal sign in between. And it's going to turn out that you'll have an equal sign in between. So let's see what example number this is. Example 6. All right, so solve 36 divided by 54, no big deal, except I can clearly see that's reducible, equals 18, still not a big deal, so it must be coming in this denominator, x plus 5. Yikes! What are we going to do with that? Okay, we panic just a little bit. I do it too. When I get a problem that I see a problem that's a little bit complicated, I'll say, oh, my little heart will pound. But that's okay. We know what to do. We breathe, we calm down, and we go, what do we know? We know first, without even thinking about the x plus 5, that we need to reduce this ratio. So I have 36 over 54. 36 divides by 2, leaving 18. 54 divides by 2, leaving 25, 26, 27. 18 divides by 3, leaving 6. And 27, 27 divides by 3, leaving 9. I thought I was going to go far enough, but I didn't. 6 divides by 3, leaving 2. And 9 divides by 3, leaving 3. So I know that this is actually just 2/3. and then I have an 18. Still wish I could reduce that, but I can't. And then x plus 5. So let's take what we know. We know that we're a little bit panicked about this x plus 5, except isn't this just one number called a binomial? All by itself, it's just a number. So let's use cross product. All we're doing is crossing one number into the one number from a denominator into another number that's a numerator. So let's do it. Do I have the ability to multiply 2 times the number x plus 5? I do. We call it distribution. That wasn't such a big deal after all. And then 3 times 18 is 30, and 3 times 8 is 24, so 54. And then 2x plus 10 equals 54. And let me see if I can get a little bit more space here. Yeah, I'm totally out of space, aren't I? All right, so I'm going to do a couple of steps at one time. So x equals, well, I have 54. I would have had to subtract 10 and then divide 2. So I just did 2 steps at one time. If you do the work carefully through, you'll see that you will get to the same place. So this is 44 divided by 2, which just equals 22. So 2 more problems for you to practice. Be sure to reduce ratios where you can before you start to operate with them so that the problem doesn't get big and ugly. And that's it for now. I'll see you in class.